It's not the easiest question. I'm assuming other than the report, right? The files were XML files, not HTML files. Yeah, it's useful to have as XML files because they are like dictionaries. You can think of a dictionary is also a dictionary, right? It has a word and it has a meaning. And also, I don't know what else was there in that dictionary. Let's see. I think there was some other stuff. Let's open one of these dictionaries. So this is the word, and probably it's other pronunciation, other spellings of the word, I think. And this is the definition: an earthy oxide of manganese, whatever. This is the word, and I think maybe this is the pronunciation with emphasis on this word. So this dictionary has a lot of things. It's also telling you what part of speech it is, that it's a noun. So it's more than just the meaning of the word and what's the source of where did they get this meaning. Most of them I think is from Webster dictionary, but this is something. So if I didn't give you just word comma meaning, word comma meaning, this has a lot more. That's why I was asking you to look for ENT and then word and then ENT. We'll later learn how to avoid that way of looking up and how to look it up slightly differently. But as we are talking about the last question, or not the last question, but the fourth question, which was about forming words. This question will continue working on this question in pieces. So if you weren't able to finish it, or if you weren't able to make much progress with that question, that's fine. We'll do this one in pieces, and then we'll extend this question to form your first project. Basically, the first project is to create like a wordscapes game and its solver. For those of you who are not familiar with that, you can download on your phone or ask your parents to download on their phones. The game is called Wordscapes. So we'll try to create a game similar to Wordscapes and then allow to solve for that. So that's the program that we'll work towards as a group project in the next 3 to 4 classes. I don't know, maybe a little longer than that. We'll have to see depending on how everybody is moving. So if you didn't finish the fourth question, don't worry about it. It's a relatively hard question and we'll continue working on that one. Okay, so the first 3 questions, were they okay? At least the first 3 questions I'm hoping were relatively.
Yeah, they were pretty easy.
Right, yeah, the first 3 questions were relatively easy. Yeah, correct. Okay, cool. So we'll continue on the first 3 questions. Okay, yeah, I'll check this. Okay, let me copy this and add it to. Okay, I'll check that. Okay, so can you guys hear me? Okay. Yeah, maybe Tulsi Arun Kumar try dialing out and then dialing in again. Yeah, Satvik, you are supposed to use the files, right? Basically, without using the files, how do you know which words are meaningful words? Unless you want to sit and look at every word and see whether it is English or not. Online dictionary.
What if you just like downloaded an online dictionary and appended it or put it in your collab session?
You can do that also. That's exactly
Okay.
what I did. Those XML files were some online dictionary.
Yeah, like I just used a
You use it.
dictionary that had all the words, so I just used that one instead.
Right. The problem is your dictionary may not have the same words as my dictionary, so my answer may not match with your answer, hence hard to evaluate. That's why I use the same
Yeah,
source.
when I tried it, it seemed to work, so.
Oh, absolutely. But same words, like my dictionary may not have some word that's in your dictionary.
Yeah.
Right. So anyway, so today's stuff. Last class we spoke about how to make functions return values back, right? We spoke about how to make them return lists or tuples or dictionaries, or how to make them return one value for each time you call the function, right? So we spoke about return and yield. Now in this class, we'll talk about how to give functions inputs. Obviously that should have been more easier and simpler, but let's see, what was the first question in the homework?
I believe it was the one where you get two numbers and you add and subtract them.
Right, okay, let's see. Here, okay. So where was the first? Yeah, here. Okay, so let's take this one. So this was the first one. Okay, sum and difference, take two numbers. So in this question, I asked you to subtract a larger number from the smaller number, but if I hadn't said that, so if I hadn't said this and then subtract the numbers, then subtract number 2 from number 1, would the answer be the same if I passed 2, 3 versus 3, 2? Very easy question, right? Yeah, so it wouldn't be the same. And why is it, all of you know why is it not the same? So why is difference of 2, 3 and 3, 2 not the same? Or what do you learn in school? Like when do you first learn this in school? Addition is something, but subtraction is not something. What thing is that? Right, it would subtract. Yeah, exactly, right? Yeah, commutative, right, exactly. So they are not commutative. So you are already familiar with operations, with mathematical operations, or with situations where one input and the second input have passing a comma b and b comma a need not return the same thing to a given function. And you guys have already studied functions in school, right? Like addition is a function of two numbers, as you studied at the beginning of your math schooling, or multiplication, you study multiplication as a function of two numbers. So similarly, subtraction is a function of two numbers and it's not commutative. So a comma b versus b comma a matters. Now, how do you know for sure, like from your function, you really can't. Let's take even a more simpler example, division, right? 5 comma 7 and 7 comma, or 5 divided by 7 and 7 divided by 5 are not the same thing. Each of them has a name, right? What is the name of your what is the name? If in 5 divided by 7, what is 5 and what is 7? Okay, so divisor and dividend. Okay, 5 is divisor or dividend in 5 divided by 7? Okay, so let's say dividend, divisor. Now obviously this function can take two input arguments and their positions are very important, right? What you pass in the first position should be the dividend, and what you pass in the second position should be the divisor. But how do I make sure that when I'm calling this function, I pass it the same way? So if I want to call here and I say division 5 comma 7, when you look at this call to the function, is this clear that 5 is the dividend and 7 is the divider? Let's say you don't see the first part. So if I just show you this part, is this clear that this is the dividend, this is the divider? Right. So it's not clear, and it doesn't have to be clear. You can obviously go to the function and you can look at what is happening. But if you wanted to make it clear, what is a way to make it clear? Any guesses? How could you make this clear? Comment. Okay, you could put a comment. 7,5. That wouldn't make it any more clear, right? What's the difference? I mean, you know, it's different. These two are different, but which one is the divisor? Which one is the dividend in either of these? Allow user to input. That's a different kind of way to solve this, right? But while calling this function, if I want to just look at the call to the function and call this, is there any way we can make it clear? Anybody? Dictionary? Okay, you could have passed this in a dictionary. That's one way. Yeah, that's a good idea. So you can create a dictionary and pass the arguments in the dictionary and pass the dictionary as the argument. That's a good way. What, any other ideas? So why a dictionary? Why would a dictionary make it any more clearer than just 7,5? Shruti Satyanarayan? It has titles. Very nice. Okay, so basically dictionary is a named collection of our items, right? Where you are giving a name to each item. So if you wanted to create this, you could create something like this: argument as a dividend, divisor, right? You could have created an argument like this, and imagine if our function accepted this as their argument. Now this is very clear, right? Even without that, if the function accepted this as an argument, it's very clear what we are passing to the function. Is this more clearer than this at least? Does anyone feel like this is better than, or this is more clear than this? Both of them do exactly the same. There is no better or worse. If you feel this is clear versus this, which one would you say is more easy to see what the arguments stand for? Dictionary, right? So obviously, because it's very clear here. What if you don't want to create a dictionary? Any other way in which you can think of making this clear? So what if I call this function like this? Is this any less clear than this? Shruti, this would be like the return of the function, right? It's almost equally clear or more clear. So these three things are three different ways in which you can pass arguments to a function. So these three are three different ways. The first one is passing positional arguments. That means the first argument goes into the first variable that the first argument goes into the first parameter for the function. Second argument goes into the second parameter for the function. Two arguments and two positions. Does it matter for the third one whether divisor is first or second? Let's see actually. Yeah, that's the point really. So here position is important basically, because if you call it this way, if your function accepts this, position is important. So before we do anything, let's just print dividend and divisor before we even and ignore, we'll keep the past still. Okay. So if I call this way, division of 5,7, okay, that should file, but so it printed 5 and 7, right? So I'll even say dividend and I'll say divisor. So when I call it as 5,7, it's automatically stuffing the first argument into the first parameter, second argument into the second parameter, as you would expect, right? Now, if I reverse this order and say 7,5, it doesn't know any better. It will assume now that dividend is 7 and divisor is 5. Now let's look at this method. What happens if I do that? So this part, I'm hoping first part is not confusing to anyone. This part is very clear to everybody, right? Sure, yeah, I'll give you my email, yeah. So is this clear to everyone? Oh, can you add somebody to waiting room? Okay, let's add. Oh, yeah, there are 3 people in the waiting room. Okay. Okay, so now let's see what if we call it this way. If we call it this way, so now it printed divisor to be 7 and dividend to be 5. What would happen if I flip the order? That's what was the question, right? What would happen if I do this? So in both cases, irrespective of the order, because I'm giving names and saying, okay, for this variable, this is the value, or for this parameter, this is the value, it works fine, right? Calling 7,5 versus 5,7, but by flipping the names of the arguments made it work equally good, right? In both cases, I'm getting the exact same answer, even if I broke the positional nature of the argument. This seems logical, right? Does this seem like a strange thing or something that you wouldn't expect? Does this, why is it printing the, oh, because in the print statement, I printed that first, because in the print, I printed always dividend and divisor. Right, okay. So one way of calling passing arguments to a function is by positionally passing them. If you have 10 arguments, you pass argument 1, argument 2. If you have 10 parameters, you pass argument 1, argument 2, and so on. Another way is by using their names, right? When you're using names, as long as these names match. Now let's see what happens if I try to call it with the name that doesn't match. Div, I'll just try passing as div. Let's see what happens. So it says div is not an expected name, right? And this is also something that you would expect, right? Because div is not something that this function understands. It only understands dividend. So this is another way of passing arguments. This is called named arguments, right? So you can name your arguments and pass them. Named arguments passing. What should you be careful of when you're passing named arguments? Right, yeah, somebody already guessed, Medha. That was a good question and good guess. Does spell check use the same type of way as problem 4, or does it use a faster way? Spell check uses a similar but much faster way, Nipun. They actually don't, you mean like, so Nipun, your question is when you type a wrong word into Google, like history, you mean this, like showing results for history, this one, right? Right, yeah. Now spell check, if you are using pure spell check, then there is no other way other than looking up against a dictionary, but it doesn't generate all the words. The way this works is, this is called distance, and we'll probably learn a little bit later about this. There are different ways to measure how far this word history is to any other known word. History is just one word, one letter away from history. Hence it shows history. But if I take some word like it no longer shows me anything, because by putting a word R here, I can make it weird. By putting changing the I to E, I can make it another word. Hence Google is no longer showing me, hey, do you mean weed or weird or whatever else? Wed, maybe I should have removed the I. or maybe this is a real word, so this is not showing me anything else. So it depends on what it guesses out to be. Like in a neural network, I don't know if spell checkers use neural networks. I think guessing ones use neural networks, like when they try to guess what word you are trying to use, those probably use neural networks, but spell checkers are very simple dictionary lookups. Unless there is a one that tries to guess your language that you are entering and then try to guess the meaning of the word. But anyways, back to the topic at hand. So when you're passing positional arguments, what is something that you have to be careful about? When you're passing positional arguments, you have to be careful about the position, right? Like you can't flip the position or you can't change the position. If you wanted to pass a comma b, you have to pass a comma b. B comma a may or may not be the same as a comma b. Does that make sense? So be careful about the order of the arguments. When you're passing positional arguments, that's what you have to do. The next thing is when you're passing named arguments, what should you be careful with? Yeah, we'll get there, Shruti, we'll get there. So you should be careful with the spelling of the name of the argument. But position is not important anymore. So as you can see, this is like one step forward than this, right? If anybody feels these two are the same, that's okay, it's your personal choice. But to me, it feels like this is one step forward because it's more clearer, or it's more clear, not clearer, but it's more clear what I'm trying to pass to the function this way. Now, when it comes to a dictionary, that's little more tricky. Now, your function should actually accept a dictionary as an argument, or sorry, as a parameter. So here, maybe we say, this is the dictionary, and we would look at dictionary of dividend and maybe dictionary of divisor. So again, very simple thing. So let's see if I call this now with a dictionary, what happens. I will copy whatever I had called here. As you would expect, it is printing dividend and divisor correctly as whatever I have passed. If I called it with 5 and 7, it would print 5 and 7. If I change the order of elements within the dictionary, should it change anything? Any guesses what would happen if I change the order of elements inside the dictionary like this? Would it matter? Nothing, no change, absolutely. So it prints exactly the same thing. Okay, so this is a third way of passing inputs to a function. Again, no difference really. The only difference is in how they become usable as we go forward. In this simple example, this is an overkill, passing a dictionary is an overkill. But we'll look at examples where this becomes meaningful in a short while. So you can pass positional arguments, or you can pass named arguments, or you can pass dictionary as arguments. So 3 ways of calling. All of them are exactly doing the same thing as of now. Obviously, the first way was the most easiest way. Right? Any questions?
No questions.
Okay, cool. Be careful about the name of the keys. Okay, so now that we looked at 3 things, let's see an example where this is useful. You guys calculated the area of a triangle in last class, right? What is the area of a triangle? Half times base times height. Okay, what if I give you the side of an equilateral triangle? Can you calculate the area of an equilateral triangle? Okay, more people in waiting room. Okay, admit. So Pythagoras theorem, use something and do something. So, but what is the area of an equilateral triangle when I give you one side? Or Heron's formula. Okay, what is the area finally? What is S for equilateral triangle? Right, square root of 3 by 4 a square, right? Absolutely. So you didn't need base or height, right? Now, would you need the, if I gave you the three sides, obviously Mugil already pointed out, if I give you that the side lengths of each side is A, B, C, you can use Heron's formula, you can do the, you can calculate the area of the triangle. What if I gave you the coordinates of the area of the three vertices of the triangle? Use distance formula, calculate the sides, and then figure out. How many of you know Pick's formula or Shoeless theorem? Right, so you can use more things basically. There are multiple ways. So let's see, Shoeless theorem. That's more interesting than Pick's formula. But okay, let's see if this Wikipedia article has interesting diagram. So if I have a triangle like this, if I know the vertices of the triangle or any polygon, then we can calculate the area of the triangle like this without actually calculating distance between the points and using whatever other theorems you guys know of. You can calculate it just by knowing the vertices of the triangle. Same thing for quadrilateral and general polygon. Some interesting topology related stuff. Then there is a special case of called Pick's theorem, where you could do this even more easily. You don't even need formulas for this. If you know that your vertices are at square points on a graph sheet, if you know your vertices are on square points on a graph sheet, you just count how many vertices are at the square points. Sorry, how many square points are there on the perimeter of the shape, and how many square corner points are there inside, and then you use some b plus h minus 2 or something, or I plus b by 2 minus 1. Some interesting ways to calculate areas of polygons. So as you can see, there are other ways. Yeah, that one, Aditya. Yeah, that Shoeless theorem. Yeah, it's actually a common AMC 8 or AMC 10 question where if you go with Heron's formula, it's very difficult to, I mean, it's time consuming to calculate area of a triangle when you know the vertices. If you use Shoeless theorem, it's really straightforward. Or if you are even lucky and use Pick's theorem, you are even more easier to find. But this only works if you know the representation of that polygon on a chart. So obviously we went tangentially. Now coming back to how this is programmatically relevant. So let's see, area of a triangle. How can you calculate, what are the things that you need to calculate area of a triangle, or how many different ways can you calculate area of a triangle? You can calculate it as equal to half times base times height, right? You can calculate it equal to square root of s times s minus a times s minus b times s minus c. How many of you don't know this second method? Okay, just to quickly show, the second method is called Heron's formula. It's actually a very old one, but not as popular because it's a little harder to follow. But something that's actually very old. This is almost 2000 years old formula. Should have been more popular than half times base times height because it works for all triangles, but I don't know why it's not as famous. Maybe because square root is harder to teach than multiplication. That's probably the only explanation I could think of. But anyway, so if I know that the three sides of a triangle are 4, 13, and 15, then you calculate the perimeter. What's the perimeter of a triangle with sides 4, 13, and 15? Yeah, we'll go work through it. 32. Then you divide it by 2, and that's called semi-perimeter. So if you divide it by 2, that's called semi-perimeter, and you get 16, right? 32 by 2. Then you take the semi-perimeter and subtract each of the sides from the semi-perimeter. What is 16 minus 4? 16 minus 13 and 16 minus 15, 1. Then you multiply these four numbers, the semi-perimeter and the differences that you calculated. So 16 times, or actually 12 times 3. What's 12 times 3? 12 times, okay, so you went with, okay, so 12 times 3 is 36. And then you have 16. What is square root of 36? And square root of 16, 4, right? So you got 4 times 6, 24. So that's the area of this triangle. So they worked out here a simple example. You can use this to calculate the area of a triangle when you know its three sides. So that's the important thing. You should know its three sides. When you know the lengths of the three sides of a triangle, right? This one is when you know the length of base and height of the triangle. This is important. You can use this formula only when you know the base and height. You can't use this formula when you know the sides, right? Next, what was the other formula? We are supposed to include all formulas. No, not now, Shruti. In the next homework, yeah, in the next homework, we'll try to get to this. And in 3 homeworks from this, we'll try to do something more interesting with this. No. Heron's formula is not better. Heron's formula is different from half into base into height, right? This is useful when you know 2 different things about the triangle. This is useful when you know some other things about the triangle. Who says you will always know the base and height of a triangle? I mean, that's what you are taught in school, but this is equally good enough to describe a triangle, right? I can say, hey, I constructed a triangle with sides 4, 13, and 15. And now I need to know its area. So it's not better or worse. It's of course more complex. This is more simpler, but this is absolutely useless if you know just the heights of lengths of the sides. Then you can't use this formula. So it's about usability, right? Not about better or worse. Now, obviously, there are special cases. Like if I know the side of an equilateral triangle, then already some of you pointed out the answer is square root of 3 times a square. I'm assuming a is the side of the equilateral triangle divided by 4. So where when a is the side of an equilateral triangle. There is a slightly more complex formula for isosceles triangle where you know the base and one of the sides. You don't need to know the base and the other side or the other equal sides. Then it is something like this, square root of 4a square minus base square. So obviously nothing interesting. Again, all of these are relatively the same when a is the equal side of an isosceles triangle and b is the other side and b is the length of the other side. So nothing interesting from a programming point of view, but something interesting from a why would you need to know its area? Oh no, you don't need to know its area, but we are trying to write an area of a area of triangle function. Now, can your area of a triangle function always say, okay, I will only work when the base and height are given? Oh, in real life, oh, actually, one of my friends is trying to build a website where they want to estimate the construction cost of your kitchen. So obviously, as you can imagine, you would need to know all sorts of areas in that, right? Because if your kitchen is 10 feet by 6 feet versus 50 feet by 50 feet, of course, that would be a very big kitchen, but obviously the cost differs, right? So you would need to know areas in real life for a lot of practical application, but the simplest application is construction. If you are doing something with construction, whether you are building your house, whether you are building your remodeling your kitchen, whatnot, or you are buying carpet, how much should you pay for the carpet? How do you compare? They price it at square feet, right? They don't price it at right amount of space. So yeah, relevance of area of a triangle to real life is very limited, but relevance of area of shapes, yes, it's relevant. So now we found out that there are 4 different formulae at least. Of course, these two just boil down to the same as this one. So we'll just write them as special cases. So I'll just say special case of Heron's formula. These two are just special cases of this. So we found 4 different ways of calculating area of a triangle. Now, how can you make your function be this generic that it accepts anything? Right now we want to write a function which you can either give the base and height or the lengths of the 3 sides and it returns the area. So how do you write a function like that? So now coming back to the programming part. Before arcs, so let's try without going towards any other things. So before we get to arcs, let's try something else. Arcs is for a different purpose. Base, height, and assign it a value. But Shruti, what would that do? That would only work when I know base and height, right? What if I know the lengths of the 3 sides? So let's see. I'll maybe try starting this with a different direction then without this ambiguous question. We'll start a little more unambiguous way. So area of a triangle. If let's say I want to include all these base, height, side length A, side length B, or I'll just say side length 1, side length 2, and side length 3. So if I include all these parameters, obviously I would then never need anything else, right? Pass a dictionary as an argument, that's definitely one way. If condition, that's definitely another way. You can add ifs. But if I had my function take all these 5 parameters, then definitely this won't beat it, right? Like whatever way I want, I can call it. But does this look useful to you? Like what if you know only base and height? How would you call this function? Yeah, exactly. Good point, Prince. Yeah, what if, so how can I make this function such a way that it is more generic? Of course, this is a very ugly way of calling this function. Assign a default value, absolutely. Yeah, so as Shruti said, assign a default value. This probably wouldn't work, right? Yeah, if you are doing this, why would this not work, Shruti? So what's the problem with this? Or does this work? Anybody, does this work? Yeah, 0, 0, right? So what's the technical term for what's the problem associated with this? Exactly, too many values to unpack or too few values to unpack really, right? Here, this one even says int is iterable, but that's even more of a problem, but that's the point. So if I wanted to call it with just these two and not these three, then I should make these parameters optional, right? I should make these parameters optional. So I will make these parameters optional by saying I'll give them a 0 value. So what does this do? What this does is now I can call this function with base and height. So let's see if I call this function with base and height. If base not equal to 0 and height not equal to 0, then return half times base times height, right? So this is what I'll do right now. Hopefully that's correct. So if I call this area of a triangle with base height equal to 4 and base equal to 2, what should I get? Why can't we put each variable associated with a formula inside a list? You can put that, Shruti, but then how do you know which variable you mean? So if I put it like this, so if my function, so good question from Shruti, if my function accepts this, okay? If my function accepts something like this, base height, side length 1, side length 2, side length 3, is this your question? Right, so this one seems like it should do, right? So let's see what happens when we try this. Okay, we'll come back to, we'll try this one in a little bit. Let's see what happens when you try this. Any guesses what would happen if I try to declare a function like this? Oh, area of a triangle with list. Okay, let's, error, okay, so, right, so it says invalid syntax because the input to a, this is called a parameter, Shruti. A parameter should be a variable. Every variable should be predefined. When I create a list like this, the list has no definition till you actually start putting values into this, right? That's the ambiguity when you declare it like this. When you declare it without these square brackets, it already knows, okay, you are going to give it 5 variables. Whether this variable is a list or a dictionary or a integer or float or a string or whatnot, that's immaterial. This is the name of a variable. So you have declared or you have defined a variable. You have declared a variable, you have not, or defined a variable, you have not declared it yet. But assign them values. No, like this. So you mean like put this here, but the same problem would happen to this also, right? Assign them values where this is not even allowing me to even define this function. Forget about even assigning values or anything, right? It's not even allowing me to define the function. Unless you mean like assign the values here itself. Is this what you mean? It still isn't working. Right. So firstly, this is not very useful, right? If you are defining the function and the inputs to the function are fixed in the function definition, then it's not very useful. Unless you are hoping you could just get away with calling it with different values. The problem is this list is a variable, right? I could maybe call it this way, where 1 equal to this, and then probably pass it this, right? This will accept it. And then where 2 could be this list. And maybe this would accept this. Even though it's not very happy about this one, because base is not defined, but it at least didn't complain about this, right? So a list made of an undefined variable is a problem, right? This variable has no definition at this point, When you make a list out of undefined variable, the list itself has no meaning at this point, unless you have already predefined these variables. Now it wouldn't complain, right? Now it complains on this one. So is this clear? So our choices are limited. Our choices are either use either use variables which each hold one value, or use a collection like a list and pass it as one variable, but then you don't know what you're passing as input, or use a dictionary. So those are our choices. But if you want to call the function with different varying inputs, actually I'll leave this. If you want to call the function with varying inputs, you have very little choice really left. So in this case, it seems to work, right? When I said height equal to 4, base equal to 2, it seems to work. Yeah, our choices are dictionaries or named parameters with optional values. But what if I want to call this now, same area of a triangle, I want to call it with side length 1, side length 2, and side length 3. Can this thing form a triangle? Can these three sides 4, 2, and 4 form a triangle? Four, 2, and 4 forms a triangle? Yes, so side 1 plus side 2 is greater than 3. So 4 plus 2 greater than 4, and 4 plus 4 greater than 2. So obviously the other is. So this forms a triangle, right? This is an isosceles triangle with a narrow base. So what happens when I call this function this way right now? Any guesses? Error. Okay, Mugil guessed it, right? So why Mugil? Why is it an error, Mugil? Anybody else? Because base and height will be 0. Because base and height will be null actually. So you didn't assign any values to base and height. But this function assumes you will always assign a value to base and height, right? If you don't assign a value to base and height, it won't work. Let's try that. So it says it has two required positional arguments, base and height, and you did not pass them, right? So I have to maybe make these two also zeros. So I'm making these two also zeros, and now it should accept, but it won't return anything because I didn't do much with it. So I'm going to copy this now and say if side length 1 not equal to 0, if side length 2 not equal to 0. Why am I saying not equal to 0 here? Any guesses? In fact, I should say greater than 0 actually, not just not equal to 0, because what does a negative length of a triangle mean? So I calculate the semi-perimeter, and then I have to calculate the square root of this semi-perimeter times semi-perimeter minus something. And then I raise that to power square root. So raise it to 0.5. So now this returns some area. Right, exactly. So yeah, not just because they are not defined, because 0 is the default. Could we possibly create different functions for each formula? You could do that, Mohanshri, but would you like to call your function differently? I mean, it's the area of a triangle, right? Irrespective of what input you're giving, it's returning me the area of a triangle. This makes it look like you have one function for both the purposes. It's a more comprehensive function than if you defined it with one for each one. Of course, you can define it. There is nothing wrong with creating two separate functions. One saying area of a triangle with base and height known, and the other saying area of a triangle when all three sides are known. then you would have to go create area of a triangle for equilateral triangle and area of a triangle for isosceles triangle, right? That would be one way, but does that look like a interesting way? I mean, which one seems appealing to you basically? Whichever seems appealing. No, it doesn't have much efficiency, right? Yeah. So if you keep creating functions for different arguments, it's just repetition of you have to know a lot more. But this function now is behaving little more uh, in a self-contained manner, whether I call it with base and height. In fact, if
Are
you
you
notice,
saying anything?
oh, can you not hear me?
Can hear you.
Oh, okay. Okay, cool. So base and height. Now, whichever way I call this, oops. Okay, let's take these two as two separate calls. So whichever way I call it, it's returning me two things. Now, what if I call it with just the base? Any guesses what it would do? Oh, okay. What would this do if I call it with just base? Would it give 0? What would be the return for this? What would it, could you please put the link in chat? Yeah, nothing, right? Yeah. So it wouldn't give anything because I was checking specifically to make sure that these two are not their default values or these three are not their default values. In fact, I can even probably say in the same else return nothing. So I can even make it return something or none. So it's not returning anything. So if I say this x equal to this and print of x, then it would say x is none. So it's returning nothing. None is a special keyword. You can use it to say when you don't want to return. What if all 5 parameters are there? That's a good question. So what if all 5 parameters are there? It would only do it with one parameter then. I mean, with one way of doing it. So if we go with this, it would still only calculate the area of the first triangle, right? Yeah, it would only calculate the area of this triangle. So this is kind of ambiguous, but this is on the whoever is calling it. At least your function is flexible, irrespective of whether the person who wants to calculate area knows base or height or lengths of sides. Your function is accepting an input and it is doing it, right? If the person who is calling your function does not know which triangle's area they want to calculate, that's really their fault, not your fault, right? So this function has some utility. So this is called positional parameters with optional arguments. We already saw this. Now let's move to a little more complex thing. What if I want to calculate the area of a quadrilateral? Obviously, there is no easy formula. Let's implement like shoelace formula. Basically, we'll implement shoelace formula for area of a triangle. And then we'll try to extend it to area of a quadrilateral. So what's shoelace formula? Of course, you don't have to know. Actually, let's skip that one. What if I wanted to write a function that multiplies a bunch of numbers? Multiply any length of numbers. So if I'm supposed to accept, my function is supposed to accept like 20 inputs and multiply them, or 40 inputs and multiply them. How should I write my function? Yes, some Prince is already gearing for that. So before we go to args, one way is I can say list of numbers, right? So I can say list of numbers and then I can pass it list. Does that make sense? Does this seem reasonable? Multiply any list. Okay, so I'll just say return, I'll assume, so product equal to 1 for number in list of numbers, product times equal to number, and then at the end return product. Oops. Right, so now it goes through all the numbers in my list of numbers and returns it. So let's see if it works. Multiply some numbers, we'll just call it multiply numbers. So if I want to call it with list with 1, 2, 3, oops, did I know? Oh, I didn't refresh this after I did it. So it returns 6, right? I multiplied this and I returned it. Now if I put 4, 5, 6, 7, 8, returns it again, right? Nothing interesting, right? I expected a list and I'm giving a list, right? Nothing interesting so far. But you have already used a function which also accepts a list of a sequence of numbers a sequence of characters actually. Right, so what does this print to do when I call it with this comma is comma a comma test? Very close. What does it print? You guys can try this on your computer. So it prints with quite some spaces actually, or some space, at least one space each, right? No, it doesn't print as an array actually, it just prints as this is a test, right? So how many arguments did I pass this one? 4. But did I pass them as a list? Am I passing? No, not really, right? For my multiplication function was accepting variable number of arguments, but I had to create the list and pass them. Whereas the print function, it's super generic. It's accepting even without me creating the list. So this is another interesting feature in Python when you pass variable number of arguments, right? So one way of passing variable number of arguments is to make your function accept a collection like a list or a tuple or a dictionary. You can make your function accept a collection, or you can do something interesting and create your function multiply numbers without list input, and you can call it as asterisk args. Somebody already pointed out this one. So we would do exactly the same thing, exactly the same inside function. But what happens is now Python automatically creates the list for you based on your input arguments. Oops, I made some mistake somewhere. Oh, I made a mistake here, not there. I was looking. Okay. No, I was making a mistake here when I was accessing it. So when I say if my function accepts asterisk args or asterisk arguments, does this work? I've never tried it myself, but let's see. So if it accepts asterisk arguments, that means you can pass as many arguments as you want. So now let's try to see with this same function returns 120, right? Is behaving exactly the same as the previous function. What's the difference? This function and this function are behaving exactly the same way when I pass the first five numbers, first five natural numbers. They are giving exactly the same answer. But what's the difference between this function and this function? Right, I don't have to create a list. In the first way, if I'm assuming my list gets a collection as an input, I have to create the collection myself. But if I just put asterisk arguments, then I don't have to keep the collection myself. I can put as many comma separated arguments. So I can separate as with comma separated arguments, or I can assume I get a list. So let's recap whatever we studied so far. There are few ways to pass arguments to a functional. You can either pass positional arguments, or you can pass named arguments, or you can pass dictionary as an argument. These are three things we studied at the beginning. Yeah, as soon as we finish another one more way of passing arguments. So positional arguments, named arguments, dictionary as argument, that's what we studied first. Then we studied optional arguments and combining optional and positional arguments. Then passing multiple arguments as a list or multiple arguments as asterisk and argument collection. Okay, now because we learned so many, so you can put as many values as you like. Yeah. So now I would like for you guys to write two easy functions. One function is sum of numbers, call it sum of numbers. Write it two ways with a list input and sum of numbers with a arguments, asterisk arguments, a special list as the input. So two inputs. Just try quickly writing something, calling it, and then share your. So try writing these, and once you are done, you can message in the chat window. Oh, okay. I could go back to this. So you can loop through this arguments collection. If you have any doubt, if you are not sure how to write this, you can let us know in the chat, and then we can split you into breakout rooms so that we can discuss with you individually. If you are not sure how to write these functions. Okay, you guys started returning it. Okay, so first one super quick, second one super quick. Very nice, very nice. Okay, nice, Shruti. Yeah, Nipun, yours is right. Did it work for you, Nipun? Sure, sure, then it's right, yeah. Okay, if any one of you is having trouble writing this function, please let us know. We'll split into breakout room. Otherwise, we'll start to mix up everything now. Not everything, whatever we learned so far. Okay, so everybody is clear. All of you know how to write these functions last time. Okay, clear. So now let's go and mix up some of this. What if I wanted to create area of a polygon, or forget even area of a polygon. Let's write a simpler function. I wanted to create a function called calculator. Very simple function. Obviously, all of you have used it. I want to create a function called calculator. What should my function accept? Operations. Okay, what operation do I want to do, right? Numbers and operators. So what am I trying to do? I'm trying to write a function called calculator, which will only do 4 calculations, not complex calculations, maybe for a few calculations. So what calculations do you want this function to do? Don't go too much overboard because it will waste time on typing. Uh, simple functions, try simple calculations. Okay, addition, multiplication. Can you share the link? Yeah, I can share the link. But don't, okay, change. Okay, so I want, all of you are saying, okay, we'll at least add, subtract, multiply, divide. How many numbers should I add? How many numbers should I add? As many as needed. Okay, add as many numbers as provided. How many numbers should I subtract? Okay, only 2. How many numbers should I multiply? Obviously, you guys will say as many as multiplied, and only 2 here also, right? Now, what if I throw square root into the mix? Only one. Okay, so we'll just take square root of only one number. Okay, so now without actually worrying about what to do, how to do, let's see how to define the function's parameters to even do this. So what is the absolutely necessary parameter in all this? As you can see, sometimes one number is sufficient, sometimes two numbers are sufficient, sometimes many numbers are sufficient. But what is an absolutely necessary parameter? Okay, so somebody said exponentiation is the same as square root, right? Yeah, so why are we subtracting only two numbers? So Medha, because it's not clear when I say subtract three numbers, do I mean a minus b minus c or a minus b plus c or c minus a minus b? It's not clear what it is that I'm expecting, right? When there are two numbers, I can at least very clearly say, okay, I'll always subtract first number from second number from first number. Okay, so any guesses? So what is an absolutely needed parameter for my function here? I need one parameter for sure, not the numbers, right? Not the numbers. If I just get two, what am I going to do with it? Right, which operation exactly? So my calculator should know which operation is happening, right? So operation is an absolutely necessary parameter, right? Without operation, I really don't know what I'm supposed to do. Now, once I have operation, what else is known to me then? Can I decide how many things I need? How many numbers are needed? But is that a fixed number? Any guesses? Is that a fixed number? No, absolutely not, right? So how should I pass a variable number? Based on operation, we can do one, two, or more. So what if I just did numbers, right? So now my function has one required parameter and one parameter that accepts a variable list of numbers or variable count of numbers. If anybody does not follow this, we'll pause this for a second and answer their questions and then continue. So you see what this function is accepting, right? If you are not able to follow, we'll definitely stop here for a second. Okay, so now that my function has a fixed argument called operation and can accept variable number of arguments, which are numbers, how do I call this function? So how should I call this function? Let's say I want to calculate the sum of three numbers. How do you expect me to call this function? Calculator of what?
I'm just living my life. Let's drive.
Sorry, what was it?
I'm just living my.
Okay, so somebody at least messaged whatever I heard someone say. So I would say add comma 2 comma 3, right? Something like this. Calculator of add comma yeah, definitely good one, Vidyut. Yeah, we would say calculator for sure, but then after that say add and then any number of arguments, right? I can hear somebody say something, but I don't know what you're saying. Okay, fine. Continuing on. So this seems straightforward, right? I could call it as add comma 2 comma 3. Is this any different if I wanted to call it this way, add operation equal to add comma 2 comma 3? Do these three things look any different? Do these two ways of calling? No, they don't look any different, right? Yeah. How about this one? Does this look any different now? No, the function does not know, Vidyut. We will make it know. The function does not know add equal to plus yet. We'll make it know. So does this thing look correct? The third one and the second one, do they look the same? No. Okay. Okay. So let's try to do this operation. If operation equal to add, then return sum of numbers, right? So let's call this different ways and see whether they all return the same thing. So the first one, as we expected, returns the same thing. 2 plus 3 as 5. Right? So Vidyut, now it knows add means add. What happened to the second one? So what looked like the right thing to do, we could have said, did I make a typing mistake in the name of the argument? No, I didn't make a typing mistake. So these two looked exactly the same, but gave me an error. I think you can't have some named and some. Okay, that looks like a good point. So how to fix it? I absolutely want to have named arguments. It didn't say I can't have named arguments followed by keyword arguments. What is it saying? Position. So dictionary or mix up here. So this is not a dictionary, right? This is how you call named arguments. So I'm trying to pass a named argument, but it is complaining that, hey, you can't do this because positional argument follows keyword argument. So some ambiguity. What if I made this an optional argument? Let's see. What if I made this an optional argument? The first method still works. The second method still doesn't work. So some ambiguity. Third method also doesn't work. Got multiple values for argument operation. So mixing variable, if you do it this way, mixing variable number of arguments with positional arguments can lead to the Python interpreter getting confused. At least it looks like it is complaining about some errors, right? To you and me, all these three things look like the same. At least when you are reading it logically, they look like the same things. But when the program is reading it programmatically, they look very confusing to it. This looks very simple to it, but this looks confusing to it. Even though to you and me, it looks more clear this way than this way. And that's happening because we are mixing positional arguments. That means this argument has to be in this position, right? Operation has to be according to it. Anytime you put a variable number of arguments, then the position of this argument is kind of fixed. So it's a positional argument followed by a variable number of arguments. Hence, this kind of named argument calling makes it fail. If it works if I don't name, because then it's taking purely by position. Because when I'm giving it variable arguments, there is an implicit understanding. When I'm giving it variable arguments, there is an implicit understanding that, hey, whatever number of arguments are coming up, I'm just going to stuff into this, except the first one, right? So this is thinking I'll take the first one, stuff it into operation, and everything else after that, I'll just stuff it into numbers. But when I give it a name and say, okay, take this and put it into operation, it's now confused. Hey, my idea was I'll stuff the first argument into first parameter, and after that, every other argument into numbers list. But now it's confused because it says, oh, you're telling me to put this into a special variable, but I don't know whether that special variable is the first variable, or maybe this has like 4 variables. So maybe I have operation and maybe some number of operators or number of digits or in number count or whatever. So now it's a little confused, right? It no longer knows, hey, for this operation, for this number count, it's simple idea of I'll take the first one, put it into the first variable, I'll take the second one, put it into the second variable, everything else put it into this list, is no longer working out when we specifically address it and say, take this operation and put it there. Right, let's see if this works. So still the same problem, right? So when you have variable number of arguments combined with named arguments, this looks like it's not working. Well, no, actually, wait a second. This is not done, right? Like, when is the break? In 5 minutes. Once I show that this is not done. So let me show you a print function again. Okay, so print this is a test. Same thing as we did last time. Now I would say end equal to asterisk. So what do you expect this to print? Or what do you expect to happen here? This is a test asterisk, but I repeated it 3 times, right? Error, okay. So I am passing a variable number of arguments along with a named argument. Would this work? Okay, let's see. All of it worked. Oh, I don't know. Maybe because it's using up some RAM when I run something, maybe. You're talking about this RAM usage here? Yeah. As you use it, it probably increases. Guys, class will end early means maybe end early by 10 minutes or 15 minutes or maybe 20 minutes. We are 1.5 hours into the class, and if you want the class to end, you can leave. Absolutely nobody is forcing you to stay. So for this function that I created, when I had simple operation equal to empty string and a list of numbers or a variable number of numbers as input, when I called it with operation equal to and at the beginning or operation equal to and at the end, it didn't work because it was complaining. But for this print function, which as we know, accepts a variable number of values, I called a named positional argument. Yes, absolutely. So print's already guessed it, right? So print function did something interesting. Any guesses what it would have done is the interesting way? And by the way, what did it do when I did this? Print, this is a test end equal to asterisk. What it did is basically print is almost like your printer. If you print line by line on your printer, if I use a simple print statement, it prints a line. If I use another print statement next after that, because this printed a line, this starts on the next line. It almost implicitly assumes I print this and then move it to the next line here. Whereas when I say end equal to asterisk, it just ends that line and does not move the next line's printing to, does not start printing the next print output on the next line. It prints, it only prints on the same line because it just has asterisk at the end of this print. By default, it assumes end is equal to line feed. This is the same thing as so it should print the same. So what happened here is print function is accepting variable values. So let me see if I can make my calculator function also accept. If I move it out of this way, out of the way of the numbers, and then give it operation. So let's see if this works any better. So my original call that failed still seems to fail. But now at least if I switch this order, does it work at least? Now it seems to work, right? Can we have another independent code challenge after the break? No, asterisk does not make two separate lines print one line. Asterisk means, so each time you you use print statement, once it prints the particular thing on the display, it also prints a new line character at the end of whatever it printed. So this is, when you print this way, it assumes that you are printing this on one line and you want the next print to start on the next line. So that's why when you printed the next statement, it started on the next line, because the first print ended this line, as you can see, with some character that you can't see here. It ended it with a character here that you can't read. But when I say, okay, end the printing of this with some other value, so now it printed this and this is the end. So when the next print starts, it can start from right after the first print ended. So by itself, no specific logic, but this is it. So what did we do? How did we change our function so that it can accept a named parameter in addition to a variable number of parameters? We had to make two changes. One, we switched around the position of the arguments. We first put variable number of numbers, and then we said operation is a fixed parameter, but at the end. So there are two ways to call this now. Let's see if both ways work. I hope there are two ways to call this. So it didn't do anything because it's now stuffing all of this into the list of numbers. So there is only one way to call it now. 2, 3, operation equal to and, unless you clearly tell it, okay, this is now going into the last operation variable, it'll keep assuming it. Every input argument that you give keeps going into the numbers collection. So we can take a break. Once we come back, we'll quickly check this. So we can take a quick break now, like maybe 10 minutes. Once we come back, we'll look at, oh, Shreyan raised hand. Okay, Shreyan, you wanted to say something? Let's come back at 11:10. Yeah.
I didn't mean to raise my hand.
Shreyan, you had some question?
I was just saying I didn't mean to raise my hand.
Oh, okay.
Hello?
Okay.
Can you hear me? Okay, sorry.
Yeah, no problem. Okay.
I think I accidentally did that.
Oh, okay. No. Okay, so break till 11:10. Anyone has any questions, you can stay back, ask. If not, you can take a short break. Okay, as you guys are taking a break, I will also take a short break. Okay, so I'm back from my break. Can you, okay, 53. So can you check this function? Yes, I can check this function. Let's see. Okay. So you sent add, subtract. Yeah, this would work. Product equal to 1, divide. Okay. Yeah, this would work, Shruti. We'll not go over the problem. That would be this. Yeah, we'll not go over the last problem of the homework completely right now, primarily because I don't know how many of you haven't tried that. So if a lot of you haven't tried it, then we'll not go over because we'll keep using the same problem. You can try it this week also if you want. We can keep using the same problem as homeworks, just extending it a little bit or maybe breaking down it a little bit to continue. Yeah, I can check your last problem later. Yeah. Okay, so we just looked at something. We have positional arguments, named arguments, dictionary or collections as arguments, and then we had optional arguments, and then passing variable number of arguments. Now, if you want to mix up variable number of arguments with positional arguments, you have to put the variable number of arguments first and then put the positional argument, or use a list. If you used a list, you could have done something else. So those are the two options. But if you want to use asterisk args or asterisk or some variable, and then you want to use some positional arguments, then you have to put them at the end. And the only way to call them is actually by calling them with their named argument call. And this is useful, as you can already see. Print statement is a very good example of where this is useful. I can print as many things as I want, and I can end it with something. So there are practical uses for this already that you have used in the past. So that's input arguments. Any questions so far on input arguments and output arguments based on what we saw last class? If not, we'll move on to the next topic on this one that we had originally planned. Okay, so we are a little behind from the schedule. So the next topic that I would like to go over is, oh, yeah, that is my profile on LinkedIn, yeah. Anyway, so we have error handling. Now, obviously your calculator function, especially let's look at Shruti's one, not to pick on her work, but Shruti implemented this calculator function, right? What's the problem with this here? Anybody? Any thoughts? Any thoughts on what's the problem with this numbers of zero? Absolutely. So Shruti herself got the problem. Yeah. Okay. So there might not be two numbers given. What happens if I just call it as 1 comma operation equal to subtract? Let's look at her calculator and let's call it with so what happens now? Oh. So it gave me an error as expected, right? Absolutely. Nipun pointed out another nice error. What if instead of giving it 1 comma operation, so let's say I give it two numbers, now it obviously works. Shruti's calculator will subtract and give us a -1. But what if instead of giving 1 comma 2, I gave it a 1 comma 2? Is this one the same as number 1? No, what is this one that I'm passing as an input now? What kind of a number is it? What is its data type? String. Okay, absolutely. So again, same problem. String and int can't be subtracted. So same problem. So we have run into these issues for a long time now, and some of you guys already know how to solve these. But one of the things that you do, obviously you don't want your calculator to break upon every small problem, right? Especially give some crazy errors like this. How do you take care of these errors? So one way of taking care of these errors is by introducing error handling into your functions. Okay. So let's say I take Shruti's function because she already typed it. I'll just copy her function. Now the errors that we just saw, what was the first error? The first error was not getting sufficient arguments. Yeah. So very good point. Actually type check. Yeah, that's some good point. So first error was not getting enough arguments. Second error was not getting right type of arguments. Not getting arguments of correct data type, of expected data type, not correct. Okay, so those were two problems. What other problems? Yes, exactly. Try and accept. Yeah, not accept, accept, I guess. Yeah. So what other errors can you think of? Based on whatever you have learned in the last 9-10 weeks ish, or almost 20 weeks. So what other errors have you guys stumbled upon or run into in the last few weeks? So we can get either not enough input arguments or not enough, not the right data type. What about operation? What can go wrong with operation? Yeah, not getting an operation. So no value for operation or invalid value for certain data type, for certain variables. Because for this simple calculator that we are programming, we only expect add, subtract, multiply, and division functionality. If it comes and gives us integration, then we should say, hey, this is an operation that's not yet defined. Right, if I give log, it shouldn't really tell me anything. Or it should tell me something. Telling me something is basically your function handling all sorts of inputs. Integration is a process. Right, you can do else. That's one possible way. Prince, you can do else. That's definitely a possibility. No, I'm not saying how to do it. I'm just saying what are the types of problems you can get when you take these inputs. Now let's get into how to solve these. So the first thing, invalid value for certain variables. How do you fix this one? Prince already had a good point. You would just say, you would, instead of using these as all ifs, you would go with if else if pairs. And at the end, put an else and say return none. Right? So if it's not one of these operations, you would just return none. This will kind of solve, if not exactly solve, this will kind of solve this. If you want, you could, instead of returning null, say not a defined operation, or you can even say operation is not defined. Something like this. Error in input operation. Sure, yeah, something like this. But how about not getting enough arguments? What do you do for that? Not getting enough arguments. Should you return something? How do you check for getting enough arguments, first of all? If arguments equal to 1, fail. Absolutely. So if length of arguments or length of numbers is less than 2, right? That's a problem because she only used add, subtract, multiply, and divide. So I'm just putting a universal one. If length of args is less than 2, then what would I do? I would say return less than 2 numbers were provided as input. Something, you can return anything you want. Again, I'll make this also an edif. So we are kind of extending the function very little by little bit, right? So we now covered this piece and this piece. We have written ifs to handle these errors. How about this one, not getting arguments of expected data type? How would you handle that? Check type. Okay, how do you check type? So not getting enough arguments was fixed by this thing. Invalid value for certain variables is fixed by this one. Now we have to fix this kind of a problem. If type of numbers not equal to int, try and accept. Okay, so a lot of you guys have different theories. So let's see, how do I make sure this is a number? When I say x equal to number, how do I know that the value that the variable x holds is a number? Type of x. Okay, someone of you said type of x. So it gave me int. So what can I do? Type of x. So how do I check this? If type of x what is equal to int. Okay, let's see. Why am I typing so badly today? Okay, else print. So it printed int, right? So this is one way you could check. Any other way you could check? So let's see if if I give it a 2, what happens? It says not integer. So this simplistic type checking is working, right? In fact, this is the most exhaustive type checking also. There are probably more some special functions, like for example, is numeric is a special function which you can sometimes use, but this one that you guys proposed initially is the best one, or most exhaustive one. It would work for any kind of thing. Oh, so x dot is numeric probably. So yeah, it looks like it takes it and it assumes. So sometimes, or is number, I don't remember what the function is also called, but is no. Okay, so type of x equal to int is a very good way to check this. Now how do you bring that about into your numbers collection here? Actually, I'll give all of you guys this as the input function. So please try to change the code such a way that oh, I only sent it to McGill. So this is the code. I want you guys to write some type checking to make sure that all the numbers here are either integers or floats. So is the question clear? Like, try to check whether the numbers that are given as inputs or whatever parameters that are given as input to your calculator, all the numbers are actually indeed either floating point numbers or integral numbers and not strings or any other type of data. Oh, okay. Yeah. Use this one. Instead of using is numeric, use this one, type of x equal to, or type of number equal to int. So you should check to make sure all numbers are int or floats. So this is what you have to check. Please try your own thing. No, we are not, I have not done any error handling yet with you actually. I'm just saying these are the types of errors. When you write a function, you should not expect everybody will call your function nicely. You should make sure your function checks some errors, checks for certain errors, like for example, not getting enough numbers or getting bad operations. Your function should check for that. Same way, you should check to make sure that if you're building a calculator function, that your numbers are actually numbers, whether they're integers or floating points. This is error handling of one nature. So handling known errors, basically. This is handling known errors. Then we'll talk about handling unknown errors. There are errors that can be created. Yeah, you can create errors though, right? Like 1 divided by 0. Or you can create your own error. Right, yeah. 1 divided by 0 is a classic way of creating an error in any programming language. You tell me what error, class, exception, pass. Is that class or from diff? What if there is an error that the computer has never encountered before? You can raise that as an error. Yeah, absolutely. You can raise it as an error. We'll look at that. You meant this, right? Or this. Okay, so if you guys have tried, please share your code. Okay, so Shruti shared code. She is checking for IN numbers. Okay, let's go to her class code and see. Yeah, Jonathan, we'll get there. We'll get to raising errors soon. But okay, let's see what Shruti did. If type of numbers equal to int or if type of is equal to float. Interesting. Did this work? This shouldn't have worked, right? This wouldn't work for any input actually at all. Yeah, okay, let's see Prince code. If type of P, nice, yeah. So because numbers is a collection, right? Numbers is not a single thing, it's a collection of numbers. So you have to look through each one. If type of P not equal to float, int or float, did this work? Okay, cool. So if type of P not equal to this, then please use only numbers. So you basically loop through every number collection. You can even do this after this, right? Because it doesn't matter whether you do before or after the length check. You can do it either places, but you can do this. So now that we have handled, I'll copy from Prince's code. This is Prince's way of fixing it. So now we figured out this problem. So as you can see, we fixed at least the known problems. Now what if there is, but we still didn't do something. When we handle the known problems, we are still returning an answer, right? We're not doing anything different, whether it is this, whether it is giving a message saying I couldn't do something, or whether it is actually giving me the answer. There is no difference here. Is there a difference when you call it? Is there a difference in how the function is behaving or responding when you gave it bad input versus when you gave it good input? Now we have made the function behave the same way, right? Whether you gave the bad input or gave a good input, it's returning an answer. Is that desirable? Okay, Jonathan sent something. Let's see. Okay, return calculation error. Return calculation error. Nice. You just need number 1 to be 0, right, Jonathan? If number 1 equal to 0, return this. Okay. So return. Okay, so you did most of them well. You didn't check that maybe that they are numbers, but otherwise this is pretty good. Also, you're accepting number as a list. You should accept number as a variable number of input arguments. So that would be the only thing. Right now it's working because it's taking this numbers here for this one. So yeah, small mistakes, but overall this works. But would it make sense for your function to return an error as in the same fashion as it returns an answer? Is there a difference between answer and an error to you guys? No, yeah, sure. I mean, once you return, it doesn't matter whether you return the answer or whether you're returning the error. But does it make sense to return that they behave similarly? Right now, it looks like they're behaving similarly, right? If I have an error, I'm returning a message. If I don't have an error, I'm returning the answer. How can, by looking at the output, can you even tell that there was an error? Unless you actually read what is coming in the output, you can't tell that there is an error, right? Because irrespective of whether there is an error or not, your function now smoothly returns one answer back. It's returning a string or a int or a float, right? So just by calling the function, you no longer know whether it's returning an error or whether it is returning a value, an answer. So there is a way to make sure your function returns two different things for when you are returning errors versus when you are returning answers. And some of you already know it. What is it? Anybody? I know for sure, like some of you know Shreyan, Satvik, Aditya, or who was that? Nipun, Prince. Can you guys hear me?
Yes.
Right. So how do you make a function return an error? Yeah, this looks nice, Shruti. Anybody? Aditya? Except exception as E, then return E. Okay. So Darren has a interesting point. So let's take this function. This was we're taking our nicely defined function. Now, instead of checking for these things, I'm going to ignore this. I'm going to get rid of this. Do as if I don't care about this part. And include this new thing called try. So try is a programming idea or a programming construct like if. So it will try to do whatever is there within the try block, same way as if does whatever is there in the if block. So if redirects control to this block, tries to do whatever is are the instructions in the try block, except if there is a problem. So what do we do? Except we'll first say maybe return there is an error. Okay, so now we took our calculator one step backwards. Let's see what happens now. 2 comma add. So x equal to 2 comma add. So it didn't return anything. What's happening? Actually, 2 comma subtract is better because that will. So it's still not returning anything. When I have two floats, it says not an integer. How do you know? Yeah, you can fix it by checking for type separately, Shruti. You check like this. Right, like that. So any thoughts on how to make it return an error? Right now it's not returning an error, it's actually not returning anything. Or let's try printing here at least. So what's happening? Because we are not calling this with operation, it's not going into any operation at all. So there is an error. So now let's call it with this. It just says there is an error, right? So whatever error is there, whether I call it with two operation subtract or what other types of errors did we check? 2 with an integer or with a string, it keeps saying there is an error. So now we are at least, now we eliminated our error checking completely for whatever error we get. We put all our code inside the try block and we assume that everything works. If anything doesn't work, then we automatically program jumps from wherever it encountered an error like this to the except section, and then you can return something special. Or you can return an error. How do you return an error? It is not specific, absolutely. Yes, that's a very good point, Prince. It is not specific. So, but it is still useful for certain purposes. There are two types of errors that a function can have. Known errors, which you can predict ahead of time, and unknown errors, which you cannot predict ahead of time. For the known errors, it is always good to do error checking like this one. You should do error checking like this for known errors. For unknown errors, you should rely on try and except, because you don't know what other thing can go wrong. I don't know. Maybe this simple function has only these many errors. Right, you can throw an error. Instead of returning this, you can throw an error. Yeah, so raise syntax error. Okay, trying to run this. It raised this error. So let's see what happens if I try this. I forgot the syntax. So throw error Python. So we can raise an error. You can either print it like this, which is absolutely fine, or you can catch the type of error and do it. So raise a class of error. So you can print the error or you can raise error. So this is one way of doing it. Or if you are catching these, you can catch certain types of errors. You can figure out what type of error. So this is called trying for something and catching the errors. What type of errors are you catching? You can try to catch a certain type of error. We'll get to that in next class. But if you're trying and finding an error, you can try to find any type of error and then just print it. Unknown errors are what are unknown errors, right? If you don't know what you don't know, that's unknown error. Somehow when this program is running, let's say the computer runs out of memory. Is that something you can handle for? Probably not. Let's say you gave 1 billion numbers as input to your calculator function. It would most likely run into an error. But does 1 billion break it or does a trillion break it? You don't know that, right? Because it depends on where you're running it. If you're running it on a supercomputer, this function with 1 billion errors, billion input numbers actually gives you answer in a second. But if you are running it on Google Colab, probably passing billion inputs to this might fail. Does a power outage break? Probably not. Yeah, unknown errors are, yeah, better said. I think Nipun said it better. It's unpredictable errors, right? So anything that you cannot predict, that's even a better way of saying functions. Predictable errors, like getting less than 2 inputs to your function is a predictable error. Getting non-numeric values is a predictable error. Getting incorrect values to the operation is a predictable error. If you get predictable errors, handle them nicely and return specific values. If you get unpredictable errors, then go with try except and then return like some standard error. That's two ways to do this. So yeah, this one will probably defer this one for a little later. Yeah, you can do more elaborate things with error checking and you can raise a lot more interesting things, but we'll stick to easier ones like print or return a string. That's good enough for now. Because yeah, Satvik has a very good elaborate way of doing this. He's trying to calculate and raise an error, and that error is checking really what is happening inside of that, and it's checking if it's numeric, then it's calculating, it's raising one type of error. If it's a space, then it's raising some error. So he's going and checking step by step on what it is. So you could do something like this. You guys can also Google and figure out some of this by yourself. If not, if you have some questions, we can probably come back to it next class. So this is about try and accept. The same thing works when you call your function as well. So anytime you call a function, you can try to call your function. So like calculator 1, 0, operation equal to divide. And then you can accept and then say print error. If you do this, see, it just says, oh, actually it even said there is an error because I already caught the error here, but let's remove this try catch here and then just try it with this. So even if I don't have a try catch inside my function, if I called my function with a try except, so I'm calling it, I'm trying to call it to get an answer. If I don't get an answer or if there is an error inside the function, now unlike this call, this one it's giving me all these stack trace as the error, but here I got a nice print error, right? So here I'm trying to call it, and in a try block, if it fails, my program just prints an error. Whereas this, when it fails, it doesn't print anything, but it gives me all this stack trace. So that's the difference between using try except versus not using. You can handle your own errors, or your program can handle errors that functions return. And when you have predictable errors, check for them using ifs or fors or whatever, so that you return some meaningful messages back. So this is about error handling. Now that since I promised today's class will be a little bit less, unless anyone has questions, this is where we'll stop. We'll come back next class and we'll pick up from here and look at this section, like filtering of lists or sorting of lists or functions, and calling by reference versus calling by value. Is there a way to detect if there is an error, no matter which type? Just an error. Will next class won't be extra long. Are we going to have class next week on Diwali? Actually, I don't remember when is the next class. Let's see. Next class is on November 14th and then November 28th. For Thanksgiving, I don't think we have a class, but November 14th we have a class. So we have one class on November 14th. We'll discuss some stuff. Then we have another class on December 5th, and then class test for December 29th. So in the next class, we'll cover this little bit more of applications of functions, and then we'll go over recursion. Then actually I have a choice for you guys. You can either do a project as your exam for November after December 19th. On December 19th class, you can either submit a project as your final exam, or you can take a test. You don't have to decide now. Yeah, you don't have to decide now, whichever you guys want. Okay. Okay. What is the project? Project is that wordscape thing. Yeah, group project, absolutely fine. Yeah, a project is what I just told you already. It's you have to build like a wordscapes builder. It doesn't have to look like a fancy app, but it should have all the pieces. We will discuss the project. If you guys are interested in the project option, we can discuss details. No, not any type of project. Then I don't know whether you did by yourself or you copied something or you had already done it last year and you're really sending it to me. So then I don't know. But if I give you the project and the blocks in the project, we'll have a way to evaluate that project and we can do that. So this class, yes, we will go with less homework. So this class homework will be calculating area of a polygon using shoelace theorem. So you guys please go learn it online. It's a relatively easy thing. You can pick it up online. You just go Google this. You can find it very easily. They have given a lot of nice examples on how to do this, right? There is algorithms here. You can probably even find an algorithm, but please don't copy directly. Calculate area of a polygon. Sorry, polygon. My spelling today has been pathetic. Using shoelace theorem. The thing is, you should not assume what polygon you are getting. You will get like more than 3 vertices or at least 3 or more vertices. And your vertices are tuples, right? So your vertices are tuples. You get 3 or more vertices and you have to calculate the area of that. So that's one question. Second question is, write a function that accepts the name of a polygon, and I'll give you the list of polygons to accept. Name of a closed shape, right? Name of a closed shape, and returns perimeter and area in named return values. You should understand what named return values is. There are 2 ways to do this. You can do it either way. So you should accept, let's say circle, your function should accept function test of circle as one argument, and then some other named arguments depending on what some dictionary of arguments, whatever you need to calculate the area and perimeter. So you should accept the name of the shape and it should accept the name of the shape and some attributes about the shape. If it's a circle, you'll get radius. If it's returning the formula, not returning the formula, returning, yeah, no report. If you don't want report, you can do report as a bonus. Absolutely, you can do report as a bonus. So one question, calculate area of any polygon using shoelace theorem. Your function should accept using a different keyboard today than I'm used to. Function should accept a variable number of tuples or vertex coordinates as input and return area. Then you should check error checking, right? Should perform error checking. Whatever errors you can think of, you should check. Obviously, we will call your function with bad inputs and check to make sure that your function is returning something well. So should perform error checking and should return a value when it works. The second one is shape and perimeter of some known closed shapes. I will give you few known closed shapes, nothing crazy. So circle, actually you guys choose what closed shapes do you want. Circle, what else? Triangle,
Pentagon.
Okay. Pentagon, okay, fine. What inputs will you give to a pentagon? Actually, let's stick to somewhat more kite. Kite is wrong. Oh, okay. Wow, you guys want very hard ones. Okay, fine. If you want it, you can have it. Okay, so I'll just take whatever you have typed so far and pick those. Yeah, you can stop now. You can stop. Pyramid is a three-dimensional thing, right? So we'll do that also sometime. Okay, I'll copy from all the way from Darren's input to this and take all this. So Darren says triangle, Satvik said circle, quadrilateral. Quadrilateral is too vague, so hard. Okay, square, okay. Heptagon, wow. Okay, decagon. Haptagon, wow. Yeah, you guys want to make it hard? We can make it hard, definitely. Okay, good. So basically the function is not what is hard in this case. It's your error checking. Trapezoid, I'm assuming. Dodecagon, okay. Decagon, okay. Trapezoid, okay. Square already popular. Square very popular. Dodecagon, hexagon, rectangle. So since you guys gave such a large list, now you can pick which of these you don't want also, because this is such a large list. They all have complicated formulas where you, yeah, exactly. Some of these are just ridiculously complicated. I'm going to remove anything that's very complex. Let's stick to four-sided shapes. If you are doing, what's the difference between a circle and a square in terms of how you define them? A circle is round, a square is not, absolutely, but both are planar closed shapes, right? So a circle doesn't have any vertices. That's a good way to say that, yeah. So it's a continuous planar curve versus a discontinuous planar curve. So it's continuous and smoothly going, and this has some corners or vertices. Otherwise, for those of you who already know this story, I mean, the area of a circle was found out by actually using area of regular polygons. So if you don't know the story, you can look up how Archimedes or not Archimedes, how Euclid found area of a circle. Maybe Archimedes, I don't remember now. Found area of a circle. It's an interesting read. If you find it somewhere online, share it or read it. Okay, so 1, 2, 3, 8 shapes. Okay, this is good enough. We can stick to 8 shapes. You should accept some arguments. The dictionary of arguments is up to you guys. Or maybe I'll define at least what arguments each one should accept so that I can write test cases for testing these. And you do again the same thing. Function should accept whatever this is and should perform error checking and whatnot. So just 2 questions for this week's homework. And you guys can try last week's homework problem. If you want to continue trying that problem, you can try. I haven't posted solution for that, and I won't post till you guys finish the project anyways. Okay, so if you guys don't have any more questions, we are done for this week. Just 2 questions homework and 1 optional report.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramastercode.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!